Welcome to Trump Wire, your trusted source for breaking headlines, global insights, and sharp analysis from around the world. If you're new here, don't forget to hit that subscribe button and turn on notifications so you never miss an update. Imagine a traveler drifting through the darkness, between stars for millions of years, carrying secrets from a distant home. In July 2025, telescopes in Chile spotted such a traveler, a faint smudge of light moving in a way that defied our solar system's rules. This was no ordinary rock. It was a messenger from another star, 3I Atlas, the third interstellar object ever confirmed. Following in the wake of Oumuamua and 2I Borisov, 3I Atlas promised something special. Its discovery electrified scientists, a rare chance to study the building blocks of another solar system. For every star in the sky, there could be trillions of these icy bodies drifting unseen. Most wander forever, but sometimes by cosmic chance, one crosses our path. 3I Atlas's sharp, hyperbolic trajectory marked it as a true interstellar visitor, just passing through. We turned our eyes and instruments toward this fleeting guest, eager to learn its story. For a brief moment, our solar system would host a piece of another, bridging the vastness between stars. The arrival of 3I Atlas reminded us we are not isolated, but part of a galactic community, all made from the same stardust, all sharing in the grand cosmic dance. The messenger had arrived and its story was just beginning. What sets 3I Atlas apart from familiar comets? Its journey and its speed. Unlike our comets, born in the Oort cloud, 3I Atlas is an outsider, racing through our system at 130,000 miles per hour. No object bound to our sun could move so fast. It's on a one-way trip. Its nucleus is massive, 3 to 7 miles across, a true behemoth among interstellar visitors. Imagine a mountain-sized relic, formed before our sun ignited, traveling alone for eons. Its steep, hyperbolic path is a mathematical signature of its distant origin. 3I Atlas isn't circling the sun, it's making a sharp turn and heading back to the galaxy. For millions of years, it's been utterly alone, witnessing cosmic history. Now, for a few short months, its path intersects our own. It's a fleeting encounter, a brief handshake across time and space. We're lucky to witness it and to ask, where did you come from? What can you teach us? This is a rare chance to study a true interstellar time capsule. The universe just handed us a mystery. As 3I Atlas approached the sun, it passed close to Mars, a rare cosmic alignment. On October 3, 2025, it came within 18.6 million miles of the red planet. Mars, already orbited by a fleet of international spacecraft, became the perfect vantage point. ESA's ExoMars, China's Tianwen-Na-1, NASA's Mars Reconnaissance Orbiter, and the UAE's Hope all turned their instruments to this visitor. These probes, designed for Mars, were suddenly interstellar observatories. Mission controllers worked around the clock, recalibrating billion-dollar machines to track a faint, fast-moving object. The Mars flyby was our first chance to study 3I Atlas up close, closer than Earth-based telescopes could manage. Early observations would reveal its size, shape, and the first hints of activity. The world's space agencies united for a once-in-a-lifetime scientific campaign. As data streamed back, anticipation grew. What secrets would this alien visitor reveal? The stage was set for discovery. Photographing 3I Atlas from Mars orbit was a daunting challenge. Mars orbiters are built to image a bright planet below, not a faint distant comet millions of miles away. Capturing 3I Atlas was like photographing charcoal in a dark room from across a football field. Engineers programmed long exposures, but had to account for both the comet's and spacecraft's motion to avoid blurry streaks. The result, a delicate dance of orbital mechanics and celestial photography. The data returned weren't postcard images, but raw frames needing careful processing. Scientists stacked images, subtracted starlight, and teased out the faint glow of the comet. The first results were fuzzy dots, monochrome, but monumental. ESA released an animated GIF. China shared images of the comet's core. These were humanity's first close-up views of an object from another star system. The difficulty made the achievement sweeter. We had captured the light of a traveler from an unknown shore. The first images from Mars revealed something puzzling. 3I Atlas had a bright coma but no visible tail. The coma, a cloud of gas and dust, showed the comet was active, releasing material as it neared the sun. But comets are famous for their long, beautiful tails. Yet, here, there was none. The likely reason? At the time, 3I Atlas was still far from the sun, just beginning to wake from its long journey. The solar heating wasn't yet strong enough to produce a bright, detectable tail. The tail was probably there but too faint for the instruments to see. This set the stage for the next act. As 3I Atlas approached perihelion, scientists expected its activity to ramp up and its tail to blossom. Watching this transformation would be key to understanding its nature. Would its tail match those of our own comets, or surprise us? The missing tail was a tantalizing clue, a promise of more dramatic sights to come. The comet's story was far from over. The real excitement isn't just the images, it's the chemistry. Comets are cosmic time capsules, preserving the building blocks of solar systems. 3I Atlas offers a chance to study the ingredients of a world far from our own. As it nears the sun, its ices vaporize, releasing molecules we can analyze with spectroscopy. Each molecule leaves a unique fingerprint in the light, revealing the comet's composition. Is it like our comets, rich in water, carbon monoxide, ammonia, or does it hold exotic molecules? If it's similar, it suggests planet-building ingredients are common across the galaxy. If it's different, it opens new possibilities for alien worlds. 3I Atlas is a cosmic Rosetta Stone. Decoding its chemistry helps us understand how planetary systems form everywhere. Its secrets could reshape our view of the universe. As Europe and China shared their findings, NASA's silence sparked controversy. A US government shutdown paused NASA's public outreach, creating an information vacuum. Speculation grew, fueled by a raw image from the Perseverance rover showing a possible comet streak. Without official analysis, it remained an intriguing mystery. Scientists like Avi Loeb called for immediate data release, suggesting the comet might show non-cometary traits. The debate highlighted the tension between careful analysis and public curiosity. Some wondered, could 3I Atlas be more than a comet? Most scientists remained cautious, but the episode showed the intense interest these visitors inspire. In the age of instant information, communication is as vital as discovery itself. The silence was a reminder. Transparency fuels wonder and speculation. After its Mars flyby, 3I Atlas plunged toward the sun, reaching perihelion on October 30, 2025. Hidden in the sun's glare, it was at its most active, spewing gas and dust, revealing its deepest secrets. ESA's JUICE spacecraft, en route to Jupiter, was perfectly positioned to observe the comet during this fiery pass. JUICE's instruments would perform detailed chemical analysis, unlocking clues to the comet's origin. As 3I Atlas swung around the sun, it began its journey back into the void. In December, it re-emerged for ground-based telescopes, offering one last look. In March 2026, it would fly by Jupiter, receiving a final gravitational kick before being ejected from our solar system forever. After that, it would fade from view, returning to the cold and dark of interstellar space. We'd be left with data, images, and memories, a record of our encounter with a messenger from another world. Its farewell marks the end of a chapter, but the beginning of years of discovery. The universe had sent us a gift, and we answered with curiosity. The flyby of 3I Atlas is more than an astronomical event. It's a moment of perspective. For a brief time, we hosted a traveler from unimaginable distance. Its visit reminds us, our solar system is part of a vast, interconnected galaxy. Studying 3I Atlas is cosmic self-discovery. Comparing our home's DNA to a distant relative, it's a story of international collaboration, ingenuity, and relentless curiosity. As the comet recedes, it leaves us with wonder and a sense of connection to the universe. The galaxy is dynamic. Solar systems exchange material across vast distances. We are part of this grand exchange, made of stardust. The visit of 3I Atlas is a beautiful, humbling reminder. The cosmos is not just out there. We are in it.